Here we got such a task. So basically it's related to modules, predicate, logic, formula. Basically it says consider a predicate R with two arguments in the formula. Here we can see, okay, for all x, y exists C such that Rxy implies Ryz. So the question is, does M entails this function hold for a module M with the domain basically ABC. Basically what's domain? Basically the domain is like this, where it covers, where it holds like some sets of elements and interpretation. Here you can see interpretation. What is it? Basically these three elements we can write in this ways, right? In just interpretation of this set. So basically, how can we solve it? Well, first of all, we say basically we can write this xy as these elements, like for example for xb, for yc we can put, right? And first of all we have to show whether rxy, like in which cases rxy is true. Let me show you. Here you can see we can say that basically RBC, RAB and RCB is true for like the function. Why? Because basically here you can see R equals like BC, AB and CB, right? In BC we can basically put as XY. Okay, this is like, this is true. Then what we do, we basically put this BC to XY. Let's do it. Okay, let me show you like solution. Here first of all, for first we put for XY this BC. Look, then R basically put it here RBC, RCZ, YC, because here you can see this X, this Y, right? XY and RYZ. Y here is this, in our case is C, therefore we put here C. Then Z, we just write C, Z. Basically, here what we have to do, we have to check whether it can be replaced, because we don't have Z, right? No, like nowhere we don't have Z, therefore we will check whether Z can be replaced by like something. To like check, we look at the previous one, like C, right? RC. Therefore from like true statements we try to find like second element C, RBC no, RAB no. Here we go, RCB, right? That means C is C matches R and R matches B and C, right? Therefore we will just replace this Z. Okay, here we write Z can be replaced by B, right? Then now we put for XY this one AB, then we put CB. Here you can see for XY we now put the second one AB. Here you can see RAB, so basically put it here RAB implies RY. Here you can see Y here is B, therefore we put here B and Z. Here you can see we don't have any Z here, like but we try to like replace it. Here you can see before that is B, right? Here we will try the element which is second element is B. Here you can see RBC, right? R matches R, B matches B, therefore Z can, we will replace by C. Yeah, then we put the third one RCB here for XC for YB, then that implies R. Here you can see Y and we put here BZ. Here we again don't have Z Therefore, we look at the previous one, B, right? We try to find which matches, so the tag contains B. Here you can see B here. Our matches, B matches, and again we will replace by C. Yeah. Therefore, since all these are true, all these found, M entails the function, this function. If we couldn't replace anything, for example, let's say, for example, here we didn't have, for example, here you can see right, for example, we didn't have this, right? Let's imagine we didn't have like this, then we couldn't replace, we wouldn't be able to replace Z, because basically after C, like before C, there is C, right? Here you can see there are no C elements, therefore we wouldn't be able to replace. That means it wouldn't entail that function. But in our case, everything is fine, everything can be replaced, therefore this module entails our function.